The accompanying data represent the weights of various domestic cars and their gas mileages in the city. The linear correlation coefficient between the weight of a car and its miles per gallon in the city is R equals negative 0.969. The least squares regression line treating weight as the explanatory variable and miles per gallon as the response variable is y hat equals negative 0.007x plus 44.528. Complete parts A through C below. Part A, what proportion of the variability in miles per gallon is explained by the relation between weight of the car and miles per gallon? This is your R squared, your coefficient of determination. Now remember from both the lesson this week and the book, that is R squared is that correlation coefficient squared. So you could just square this, that 0.969 squared, to get your answer here. I'm going to show you really quick how to find it in StatCrunch just so for other problems or for the final. So once we open our data set in StatCrunch, we're going to go to Stat, Regression Simple Linear, select our X and our Y variables. Now, I'm going to tell you for Part B, I know that we're going to need our residual plot. So I'm going to show you where to do that. And this is a pretty easy thing to do whenever you run your linear regression, just in case you want to look at it. So we're going to scroll down to Graphs. And you see their fitted line with plot is automatically selected. So we can leave that selected just to get a good look at it. But we also want our residuals versus X values. That's the residual plot. Click Compute. And let's move this over a little bit so we can see it while we're looking at this as well. So as you see here, our correlation coefficient is the same. It's that negative 0.969. And our equation, our linear regression line is the same also. So for our slope, we have that negative 0.00698. Now, once we round it, we would get the same thing as that negative 0.007. And our intercept is 44.5279. Again, if we rounded it, we would get that 44.528. So you see how that we get all the same answers. Again, if you had wanted to just square this answer, this number, you could have done that. I'm just, again, showing this to you just for reference. So here, the proportion of variability in miles per gallon explained by the relation between weight of the car and the miles per gallon is that R squared. And again, here we're dealing with a percentage. So we're going to multiply it by 100. So that's going to give us 93 point, excuse me, once we keep rounding, see how that 7 rounds that up. Once we keep rounding, we're going to end up with 94.0. Let's click check answer. Good job. All right, construct a residual plot to verify the requirements of the least squares regression model. Choose the correct graph below. Isn't it great that we just did that? So that's our regression line. Here's our residual plot. So you can do a quick look. Obviously, we don't have that line right here. We obviously don't have this straight line. So it's either going to be A or D. Just looking quickly, I can tell you right here, we've got these 2 points down here that match up with these 2 points down here. This is what we're looking at is A, but you can easily eyeball and check up the other ones. All right. Interpret the coefficient of determination and comment on the adequacy of the linear model. So again, that coefficient of determination, that's the number we found in Part A. So we can go ahead and just put that there. 94.0% of the variance in, this is where it gets a little, like, I'm sure confusing. This is when we look at it looks at the variability in the response variable, or the variance in the response variable. So here, weight was our X, our predictor variable. Y was gas mileage. So 94% of the variance in gas mileage is explained by the linear model. The least squares regression model appears to be appropriate based on the residual plot. Remember, the residual plot, if it shows no pattern, no discernible pattern, that implies that the linear model is appropriate. So here you would see a pattern. Here you see a pattern. In this one that we showed as our residual plot, there's no pattern. So we can say that it's appropriate. So check answer, well done. All right, that's number 13 for Module 6. If you have any questions about that or anything else, let me know.